Finally, let's look at some graphs and functions. Recall that a graph can be used to represent a function. Specifically, every point on a graph is a representation of an input and an output. And if we plot the outputs for every single input, we put an infinite number of dots on this graph, we will get the line that represents the function. So let's say we have a graph, and we know that the point 3, 7 is on our graph. Remember, that's an input and an output. That means if we input 3 into our function, then we'll get out 7. So we could represent this as f of 3 equals 7. Because once again, the thing in parentheses is our input, and whatever it equals is our output. So let's look at this graph. This graph is called a parabola. Doesn't matter what the equation of it is, we can still evaluate this at any number of points just by looking at our inputs and seeing what the corresponding output is. For f of -1, remember, this is our inputs. We're going to look for -1 on our inputs, which is right around here. And when we input the number -1, well, where's the graph? The graph is way down here, and our output is also -1. F of -1 is also -1. Neat. Let's switch colors. What about f of 0? Well, our input 0 is right here, but the output is all the way down here at -2. So we could write f of 0 equals -2. And finally, f of 2, well, the input for 2 is right here, and this time the graph is way up here. The output is also 2. So we could write f of 2 equals 2. Now, it turns out we could also write an equation for this graph. We could have written something along the lines of f of x equals x squared minus 2 and evaluated this function at our inputs. However, we don't always know what the equation of our graph is, but we can always read our graph. With that, there are dozens of practice problems for you to try. If you're comfortable with these topics, you should be prepared for Friday's algebra skills evaluation going over these same concepts. Good luck!